Hello, welcome to the second module of cybersecurity, and we'll be talking about computer system, network, and internet fundamentals. And this will be expanded into computer hardware components, having an understanding of the software and operating system, the types of operating system that we have, basics of computer networking. We will also look at the local area network and wide area network. We will look at internet architecture and protocols. Also, we will briefly look at the TCP and IP and also the OSI models. And lastly, we will look at network device and their functions. This module introduces us to the foundational technological building blocks underpinning modern digital system and cybersecurity. And you having an understanding of how computer system operates, the network, how the network are structured, and also data is being transmitted across the internet is very important for you to be able to comprehend system vulnerabilities and cyber threat propagation. And looking at computer hardware components, we have what is called computer hardware, and this comprises of physical components enabling data input, processing, storage, and output. And having an understanding of this component is very important in cybersecurity, as hardware vulnerability or unauthorized physical access can compromise system security. And we have different components, and this is divided into the central processing unit, the memory component, the input or output device, and the we have the motherboard and also the power supply components. And just like I said, it's a physical component which enables data input. And it's very important to quickly look at this component. The first, which is the central processing unit, is the brain of the computer in executing instructions and also controlling data flow. And its performance influences encryption speed and threat detection. And for memory components, we have the likes of it actually stores data and instructions, and the example of these are the RAM, ROM, the HDD, which is the hard disks, and also the SSDs. And securing this is very, very important as attackers target stored data for theft or manipulations. Also, we have the input and output device, and this allows users to be able to interact the likes of keyboards, monitor. It helps the users to be able to interact, and the compromised input device can facilitate attacks like key logging and the likes. And we have the motherboard, which connects all components. It's the central which connects every component together. And the power supply unit actually provides the power. And failure or tampering here can disrupt operations and security of the data that is being stored. Let's look at software and operating system. Software and operating system. And when we talk about software, it's actually direct hardware operations and is a major cybersecurity focus due to the susceptibility to vulnerability. And system software like operating system manages hardware and provides a platform for application. And just like you can see in the chart, you see software, we have also the system software, we have application software, we have the utility software also. And when we talk about the system software, it actually manages the hardware in terms of the OS operating system. Another is the application software, and these have specific tasks. They are used for specific tasks, the likes of Word, browsers, emails, and the likes. We also have the utility software, and for this one, it actually maintains and optimize. It's for maintenance and optimization. It's for maintenance and for optimization. And example of this is the antivirus. The antivirus is an example of this. And looking at the operating system, it's actually the core software managing hardware and software resource, providing a user interface. And key function includes processing, memory, filing, and also device management plus security and access control. And in dealing with this, we see that OS are primary targets for cyber attacks, and vulnerabilities can lead to unauthorized access, privilege escalation, and malware installation. And regular updates and secure configuration is actually important in this aspect. We have types of operating system. We have the single user operating system, which is designed for one users at a time. Yeah, that's Windows, Mac OS, and the likes, and it requires strong authentication and access control to prevent malware. And for multi-user OS, it allows simultaneous access for uh, multiple users. And example of this is Unix Linux server, and it demands strict access control and monitoring to prevent insider threats. We also have the batch OS, and for this, it processes job in groups without interaction, and its security focus on job authorization and data integrity. The next type is the real-time OS, and this processes data with strict time constraints. An example of this is industrial control. And security breaches can have several physical consequences. We also have the distributed OS, which manages independent computer as a unified system, and it requires strong network security and trust management across nodes. And the last one is mobile OS, and this is for smartphones and tablets. Example include Android, and then security focus on app permission, sandboxing, and encryption. The basics of computer networking. Computer networking connects devices to share data and resources, forming the backbone of modern communication. Networks enable file sharing, internet access, and also centralized resource management. And the components of this include device, which is computer, server, smartphone, and for transmission media, it requires wired, or which can be cable, and wireless, which is Wi-Fi. And for network device, routers, switch, and hub are important components in this aspect, and also protocol. And this deals with rule for data communication in terms of TCP, IP, HTTP. And types of network by size. We have types of network by size, and this can be local area network and wide area network. We also have the metropolitan area network. We look at the LAN and WAN briefly in the coming slides. And for metropolitan area network, it actually covers a city. Wide area network covers a large geographical area like cities and countries, and the local area network covers the small geographical areas like home and offices. And it's actually important. Networking introduces security risk. Attackers exploit vulnerability for unauthorized access or data encryption. Key measures include monitoring, firewalls, and also encryption. For the local area network, and the wide area network. They are fundamental classification based on geographical coverage, and they form the backbone of digital communication. For the LAN, it actually connects device within a limited area, just like I said, the home, office, and the likes, and it's owned and managed by a single entity, offering high data transfer speed. And it's easier to monitor and secure, but internal threat remains a risk. And for wide area network, it spans large geographical area connecting multiple lands, and it relies on public and private infrastructure, generally with lower speed, more vulnerable to external threats, requiring encryption and firewall and VPNs. We also have the internet architecture and protocol. And when we talk about this, the internet is a global system of interconnected network, which is built on standardized architectures and communication rule, which is the communication rule is the protocol, and it's layered, decentralized design ensures scalability and reliability. And when we talk about internet architecture, it actually consists of end devices, access networks, and high capacity core network. And this layered design allow continuous growth and fault tolerance. And also we have the internet protocol, like I said, they are standardized rule for data transmission, and they ensure effective communication across diverse systems. We also have the TCP or IP model, and this is the internet's foundational framework with four layers. That is the application, the transport, internet, and network access. And it's practical and widely implemented. And for OSI model, it's a 7-layer conceptual framework for standardizing network communication, and it's invaluable. It's invaluable for network design, troubleshooting, and cybersecurity analysis. We have network devices and their functions, and we have the likes of the NIC, which connect device to a network, and we have the hub, which is basic device broadcasting data to all network devices, and we have the switch also, which intelligently forwards data to intended recipients using MAC addresses, improving efficiency and security. We have the router, which connects multiple networks, routing data packets using IP address, and critical for fire walls and network protection. You have the modem, which enables digital devices to communicate over analog media. We also have the access point, which allows wireless device to be able to connect to a wired network, and must be secured with encryption to prevent unauthorized access. We have the firewall, which monitors and control network traffic, acting as a barrier between trusted and untrusted network to prevent breaches. And lastly, we have the gateway, which it is a bridge between network with different protocols, performing data translation. In conclusion, the module has been able to comprehensively provide a technical foundation for understanding modern computing environments and cybersecurity challenges. And having the knowledge, you've been able to have the knowledge of hardware, software, and operating system. And this helps to be able to highlight how digital devices process data and manage resources directly, which influences security strength and vulnerability. And the understanding of network fundamentals equips you as a learner to be able to comprehend data flow and potential security risk. And this module serves as a vital bridge to advanced cybersecurity topics, laying a strong foundation for analyzing threats, understanding attack vectors, and also appreciating system and network design in defense. Thank you for listening.